Okay, continuing on now. So we're going to start with number 6, where they start talking about multiplicity. So the multiplicity is just like how many times, like the exponent on the x minus r. So like if we had this, and this is how they write it on yours, the multiplicity goes here and our zeros go here. So multiplicity goes here, zeros go here. So when we go to write this one out, when I first looked at this, it really confused me, and I'm going to highlight it for y'all so y'all don't get, so this, we have this 0 with that multiplicity. And we have the -4 is a 0 with the multiplicity of 2. So number 6, when we write this one, we'd have, trying to think about how is the best way to write this not to confuse everyone. So zeros, we have -3 with the multiplicity, I'm not going to write it all the way up, of 1. And then we have -4 with the multiplicity of 2, and it's going to be to the 3rd degree. So when I write these out, I'll do my x subtract -3, multiplicity 1. And you don't have to write the 1 there. I'm just going to try and keep them like. So x subtract -4, and that multiplicity would be 2. So let's simplify these. So I'd have x plus 3, I'm not writing the 1 again, and x plus 4, but this one is squared. So when I go to simplify this one down, I'm going to have to square that binomial x plus 4. So I'd have x plus 3 times x plus 4 times x plus 4. So x squared plus 4x plus 3x plus 12. And I haven't used one on, so x squared plus 7x plus 12 times x plus 4. X cubed plus 4x squared plus 7x squared plus 28x plus 12x plus 48. Yay! And then combine like terms. So x cubed, all positive. So plus 7, 8, 9, 10, 11. X squared plus 8, 9, 10, that'd be 40. Plus 48. And that would be your answer. So that's number 6. I'm going to write this on this paper. So we'll make our little note. Paper. I don't know if I'll be able to write any of these on here, so it's probably useless to write it this one. X cubed plus 11x squared plus 40x plus 48. Okay. Big thing here is this. And there's a formula for the ones where we have points. There's this one, and then there's one that has y-intercept. And I should probably work them closer together than the other ones because I guess it don't matter. The next ones are all like vocab ones. Oh, so on this one, there's this formula, and it's f of x equals a, where we're trying to find this a. And we have x subtract r1. And there can be as many r's as there are zeros, r2. But we only have 3 in r's, so we're only going to go to r3. And we're going to work this problem out. We're going to substitute in our x and our y. And then we're going to solve for a, and then work the problem out again. It sounds awful, but it's no. Okay, so number 7. Our zeros are -2, 3, and 5. So I'm going to go ahead and get this x minus r1. I'll write the formula here too. So here we go. I'm going to go for this part first, right here. So I have x subtract -2, x subtract 3, and x subtract 5. Okay, now then the point they gave me, we're going to pull that back up here, 7 and 216. This is my x and my y. I remember that f of x equals y because they are the same. They're interchangeable, a function notation and a y. But the function notation is all the points where y would just be 1 point. We have 1 point, so we're going to switch to y. Okay, so now I'm going to rewrite this and have 216 because this equals, I don't know a. We are solving for a. Okay, now my x value in all of these is now 7. So I have 7 plus 2 times 7 subtract 3 times 7 subtract 5. So 216 equals a times 9. 7 subtract 3, 4. 7 subtract 5 is 2. So 216 equals a. 9 times 8 is 72. Right, 9 times 9 is 81. Okay, I don't know what 216 divided by 72 is off the top of my head. I know that isn't special. Okay, so calculator, 216 divided by 3. Because calculator. Okay, now we're going to take this 3 and this up here and then multiply it out. So we have, where do I want to write it? 3 times x plus 2 times x subtract 3 times x subtract 5. And then we'll solve. So, or simplify. 3x plus 6 3x times x, 3x squared, 3x times 3, subtract 9x, 6 times x plus 6x, 6 times -3. Simplify. So 3x squared, subtract 3x, subtract 18, times x, subtract 5. 3x times x would be 3x cubed. 3x times a -5 would be subtract 15x squared. -3 times x, so -3x squared. -3x times -5 plus 15x. -18x. 18 times 5. It's a negative times a negative, so it's positive. Maybe. Okay, combine like terms. I have these and these. So 3x cubed, both negatives, so -18 x squared, 15 subtract 18, -3x plus 9. And that would be the answer. So, yeah, you're just going to have to remember you have to solve for a first and then simplify your equation. So let's write that on here. 3x cubed subtract 18x squared subtract 3x. Okay, go cap time. And these are on my other papers that I've done. So our first one is if r is a real zero of even multiplicity of a function f in the graph of f blank the x-axis at r. So on this one, when you think of an even one, I want you to think like x squared. So you know like the graph of x squared is a parabola. And then x to the fourth would have been a steeper one. But it's just touching that x-axis. So even ones just touch the x-axis. Where odd ones are going to cross, because if we had an odd one, where do I want to write that? Put it right here. Odd ones like x cubed. that cube function, you know, it comes up in zigzags. So just evens touch, odds cross. Okay, the next one, complete the sentence below. The points at which a graph changes direction from increasing to decreasing are called turning points. And that's on the papers as well as now on here, which I'm also going to upload. The blank of a real zero is the number of times its corresponding factor occurs. I believe it's multiplicity. I wrote it down there. So let's just double check so I don't tell you wrong. The multiplicity of a real zero is the number of times its corresponding factor occurs. Done with that page. When you're finding turning points, I should have put a couple more of these on there because they're really nice and easy. You take the highest exponent and you subtract one. So like that graph of x squared, it had one turning point because it just turned here. 2 subtract 1 is 1 turning point. On this one, it turns here and here, so 3 subtract 1 is 2. This one has 2 turning points. So we always take that highest exponent and subtract 1, so we'd have 5 turning points. So there. Determine whether the following function is a polynomial function if the function is polynomial stated true. So on this one, we can simplify this, and I hope y'all remember that. So we'd have 6 over 5 subtract x to the 4th over 5. And that would be a polynomial function. We're just dividing everything by 5, so we split it up. And so this one is, and the degree is still the highest exponent. Then the polynomial in standard form is g of x equals, and so they want us to write it in standard form, so we'd have x to the 4th, and this is negative, over 5. It just says iPhone, and I'm not sure who just logged on. I'm going to go ahead and finish this and then deal with that in a second. So with the leading term, our leading term is the first one, so negative x to the 4th over 5. Be sure you put the exponent with that 4 and then put it all over 5. And then the constant is a number that has no variables, so our constant would be 6 fifths. There's only one problem left, so let's go ahead and do that real quick. Construct a polynomial function of f with the characteristics. Right here is the one they give us this y-intercept. Remember that this is 0, negative 12. For it to be the y-intercept, it has to have an x value of 0. So we're going to use that function f of x equals a times x subtract r1. And since we have 3 zeros, x subtract r2 and x subtract r3. Okay, so we have x plus 2, because subtract negative 2, x subtract 1, and x subtract 3. And we're going to solve for our a, so we're going to tack on our negative 12 equals a. So negative 12 equals a times 0 plus 2. 0 subtract 1 and 0 subtract 3. Negative 12 equals a times 2 times negative 1 times negative 3. So negative 12 equals a. Negative times negative positive, 3 times 2 is 6. So negative 2 equals a. Then we're going to plug this information into this to find this. So we have a negative 2. This one doesn't have an a at all. This one's positive 2. This one has a square here, so let's see. All right, I'll get these posted.